Hi, my name is Kevin Gao, and my experiment is on the effect of magnetism on plant growth and health. When I was researching online for possible experiments, I came across something that said that magnetism really did affect plants, and I thought this was rather interesting, so I decided to check it out for myself. Materials. I use one bag of 24 or more radish seeds, two horseshoe magnets of different strengths. One is 0.33 Tesla, one is 0.49 Tesla, one bag of soil, one ruler to measure the heights of the plants, 3 styrofoam cups, and water. This is my procedure. So, first I filled each styrofoam cup about 3/4 full with soil, and I numbered them 1 through 3. I placed 8 radish seeds in each cup, evenly spaced in a circular formation either side so that there is some space in the center. The space is for the horseshoe magnets if it is a cup that uses one. So the first cup doesn't have a magnet, it's our control. In cup 2 we place the weaker magnet, and in cup 3 we place the stronger magnet. I watered each cup lightly, and I also made sure that each cup was watered equally. It's a controlled variable. Also, each cup was placed in direct sunlight, and the humidity levels were consistent. I observed each cup over the course of 3 weeks, and recorded plant height, color, number of germinated seeds, and any additional observations in a data table. This is a picture of my experimental setup. So you can't see them right now because the seeds are, of course, planted, but they would be arranged here, 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 and here. That's the same for all 3 cups. So this is a picture of the end after the 21 days. So as you can see here, this one has no magnet and is clearly the shortest of the bunch. This one is the weaker magnet, and while it seems to have around the same number of plants in the stronger magnet, it appears they're not as healthy, as the stems are not stiff and upright, unlike this one. This is a graph of the results. So it is clear here that the one with the stronger magnet, 0.49 Tesla, is increased higher and ended up greater with the greater number of plants. And also you can see a trend here. The one with no magnet was lowest, the one with 0.33 Tesla magnet was second highest, and of course the strongest magnet yielded the greatest results. So I thought this was completely strange, because why would a magnet affect a plant? So I looked it up, and I found many different theories, none of which I can actually tell for sure if are correct. One of the theories was that each plant has a frequency. I'm not quite sure how this frequency is determined, but it says that the theory says that if the magnetic field's frequency matches that of the plants, then the plant would show accelerated growth and faster germination rates. Another theory I read was that it had something to do with ferritin. Now ferritin is a protein, I believe, that is the storage capsule of iron. It is found in all beings, plants, animals, bacteriophages. So it was that ferritin, ferritin not only stores the iron, it also regulates the iron usage. So I believe it had something to do with increased iron, letting out more iron due to the effect of the magnetic field. This is something that I wasn't quite sure. It was quite complicated. One thing that consistently appeared was the Moss-Spire theorems. So that is something that you can look into if you're interested. In conclusion, for radish plants, at least, the results provided evidence that magnetism accelerated growth rates and germination times. The reason I said radish plants is because it might have been because radish plants had a frequency that happened to match one of my magnets. And these results might not be the same with different types of plants, which is something that I will change the next time I do a similar experiment. For one, in this experiment I only had 3 cups, which is not a lot. But the reason I only had 3 cups was because I had a small time frame, only 21 days, so I decided not to make it too complicated. Well, thank you for watching my video, and yeah.